Hello everyone. In this new tutorial, we will see how to visualize ELF results. These results are generated by TopChem2 from the standard output files. They include attractor locations, attractor properties, and topological features of the electron localization function, or ELF. After running your calculation with the graphical interface, you normally obtain two main output files. The POP file is used for the analysis. You can check it by clicking View POP. This file contains the standard results, especially the basin populations. This tutorial focuses on the visualization of ELF properties. First, you need to select the correct file. It is normally selected automatically, but it is better to check it. Here, the CP descriptor ELF XYZ file is the appropriate file. It contains all attractor locations found by TopChem2. It also contains the main topological features. We can now look at the properties of the orthonitrophenol molecule chosen for this tutorial. Click on View Output Structure, and the molecular viewer opens. We can now see the positions of the atoms and the locations of all attractors. For example, we observe the two lone pairs on oxygen, and another attractor in the nitrogen-oxygen bonding region. Now, you can hide this visualization. To draw an ELF isosurface, go to the isosurface menu and load the corresponding cube or cubes file. The cube file is now loaded. We can then adjust the ELF value with the dedicated slider. We now observe a typical distribution of ELF domains. You can select the standard colors using the synaptic order cube file. We can now see different colors for the synaptic order. If you want the standard ELF colors, select the appropriate color palette, called ELF basins. Now we have the standard colors. You can also use the slider to change the opacity of the isosurface. Now you can see the locations of all attractors. For a clearer view, you can modify the size of the attractors using the critical point radius slider. OK. You can also modify the shape of the critical points. For me, the best shape is the simple three-dimensional cross. Now go to the Plots menu and open the Two-Dimensional Maps section. First, load a new cube function for ELF. After that, select the desired plane. OK. You can move the selected plane by holding the Shift key on your keyboard. With the selected plane, we can observe the attractor locations. We can also observe the separatrix surfaces of the ELF basins, and then infer the basin contours. Here, for example, we see a carbon-carbon bonding basin. Now go to the population section. The basin population can be selected directly in the interface. For example, here is a protonated basin with its population. Here, we have a carbon-carbon bonding basin population. Here, we have the population of a lone pair on this oxygen, and so on. In short, you get the idea. We also have access to a local analysis. To finish with the local attractor analysis, we can display the local value of the electron density. We can also display the ELF value calculated at the attractor location. Now, let us finish with a short animation. That is all for today. Thank you, and see you in the next tutorial.